educational series dedicated to Ethereum improvement proposals and features of upcoming upgrades. I'm your host, Pooja Ranjan, and today we are going to talk about soon going to be an EIP-3675 upgrade consensus to proof of stake, which is expected to bring the Ethereum community yet another step closer to the merge. The merge will be the biggest upgrade to switch the proof of work to proof of stake consensus mechanism. To talk about the proposal, we are joined by Mikhail Kalinin, who is a researcher and developer at Consensus. Welcome to the show, Mikhail. I have been following the merge discussion and I'm looking forward to what this brings. I know the community is also eager to learn about the proposal, but before we begin the discussion, I'd be curious to know how Mikhail Kalinin ended up with Ethereum community. So let's kick off by a brief introduction.
Thanks, Pooja. Thanks for inviting me. I'm very pleased to be here. Yeah, a bit about myself. I've joined Ethereum in 2015. This is happened like 6 years ago, right before the Frontier launch, a month before it. And by that time, I've joined the small group of people who have been working on who have been working among the first entities and teams in the Ethereum space. We've been working on one of the old mainnet clients that is deprecated at the moment, and yeah, a lot of things happened there. After that time, we joined the ETH research and development project. Started to work on the beacon chain implementation in Java. Thanks a lot for Ethereum Foundation and their grant program. Then we joined Pegasus, and here we are. Currently, I'm leading a team of an R&D team that is devoted for ETH research and development. And my occupation is the merge stuff. I've been here for 1.5 years already. So joined this merge project in the January of previous year. So that's a bit about myself. Living in Siberia, working.
Thank you so much for your introduction, Mikhail. So without further ado, let's peep in.
Okay, so yeah, here's the upgrade consensus to proof of stake. Yeah, sorry, I will move my head to this screen and to that screen. So yeah, sorry for that. Anyway, yeah, so the upgrade consensus to proof of stake EIP. This is obviously about the merge, and we will start from going into the weeds of this EIP from the header, as usual. Here is the preamble for this EIP. As you can see, I'm one of the authors. The other authors are very well known, or Danny and Vitalik. This is the core EIP on the standards track. As Pooja just mentioned, it's not an EIP yet. It's just a pull request for this moment, but I hope it will turn into the EIP, into its draft state soon. Yeah, it's the category is core because it introduces the changes to the core protocol, which will need to be adopted by all mainnet clients. Here is the link for discussion. Yep. Then, yeah, the motivation section. I would like to stay here for a bit on why this EIP is happening. The motivation behind introducing the proof of stake is out of the scope of this document and can be seen in the EIP 2982, which is Serenity Phase 0 and describes the beacon chain and a lot of stuff. And the motivation behind the proof of stake is well documented there. So please, who are interested in that in particular, go by that link and see the motivation section here. What else to mention here is that the beacon chain has been online since December 2020, and we haven't faced with any safety or liveness failures so far, which demonstrates its sustainability and readiness for securing the mainnet. So yeah, this is the time for doing the merge actually. So that's all here in the motivation. And yep, go into abstract section. This is actually the description, what this specification is about. It's about the superseding the proof of work, the existing proof of work algorithm with the proof of stake driven by the beacon chain. And yes, here is the link to the beacon chain specs repository. Yes, so this the beacon chain specifications are sitting a different place other than the EIPs. So this was, I guess, discussed a lot during this 2982 EIP process. So we're not supposed to discuss it here, I guess. Yeah, the changes that are introduced by these specifications go to the block structure and block processing, fork choice rule, and network interface. Those are the main sections of specification. And I'd like to highlight the rationale behind all these specifications. So the general idea of these changes. So this is actually the minimal viable version of the merge. There were like different versions previously that we were pondering with, and yep, this minimal one that does not introduce a lot of break and change, like breaking the block format, eliminating the like one chain and substituting it with the other one, which is the beacon chain. Those are not going to this specification, and the reason behind this is that merge is the chains hot swap in the underlying consensus mechanism is already a very complicated thing, and we don't want to bring more complexities that is not necessary for doing this swap. And all those cleanups and all that we might want to do will be introduced in separate upgrades, which will be after the merge. So that's the general line here, and yeah, we will get back to it like throughout this presentation. But before we go into the weeds of into the details of specification, I'd like to zoom out for a bit and just give you a brief, very high-level introduction of the system, how it will look like after the merge. So sorry, let me just do this shortly. Okay, so yeah. Okay, so we will see after the merge on the blockchain side. So here is the actually beacon chain, and yep, yeah, this is the representation of the chain after the merge. And you can see that there is the proof of stake blocks here, which are denoted in the specification, and they are existing in a form of execution payload that is embedded into the beacon chain. So every execution payload maps one-to-one on the respective proof of stake block and back and forth. So the beacon chain becomes responsible for producing the execution payload and producing this execution chain. By the way, execution chain is the continuation of Ethereum mainnet chain as we know it today. Even the block format stays the same. The beacon chain or consensus chain becomes responsible for the fork choice. So it knows what is the head of the chain, and only the beacon chain knows what is the head of the chain. And so forth, it's also responsible for consensus rules verification. We'll see it later. So here we are. But what is important here is that this execution chain retains This is important for services, for JSON RPC, for a lot of infrastructure and tooling that uses these, that are heavily relies on this chain and its format and its block format. On network, we will, after the merge, we'll see two networking stacks. First one is the beacon chain network stack, which is responsible for consensus duties. It has like these attestations that are votes for this or another block. And there is the beacon block gossip, which will supersede the block gossip of the execution chain. So it will not exist anymore because this this block gossip that we have now on the mainnet will become unsafe after the merge because it does not know anything about the consensus rules and how to verify them. But execution chain will keep the transaction pool. So all the transaction will be collected by the execution clients and then will go into a block, which will be produced by the beacon chain proposers, but with usage of execution client software. Okay, so it also, the history sync remains and the state sync remains. So those services that will use, that are relies on the history sync, for example, or on archive nodes, will be able to keep doing this after the merge. Yep, that's the client architecture. So after the merge, we will likely see two pieces of software, which will represent the Ethereum client and which are communicated in the via the RPC facade. So here is the consensus layer, the consensus client. Here is the execution client on the right side, and consensus client drives the communication. So it sends kind of messages, comments, to like produce block, to insert block once it's received from the wire via the block gossip. It's also responsible for fork choice, as it was mentioned before, and so forth. The execution client keeps being responsible for the EVM, for the world state, or Ethereum account state, as we know it today, and for maintaining the execution chain and transaction pool. And what is also very important, the JSON RPC. The JSON RPC stays almost the same, with a couple of exclusions, like the get work stuff, which is completely related to the proof of work. Yep, and the set of methods and their semantics will, in most cases, remain the same. Okay, so that's the quick overview. Let's get back to our EIP, and let's get back to start from the definition section. There is a couple of like unusual definitions in this EIP, unusual with respect to other EIPs. That's because it involves a third party, like it involves an external party, like the consensus layer, the beacon chain, and also it introduces the new hard fork process. So we will go through the details of this one by one. Yep, the consensus layer or consensus client is abstracted away in this EIP by introduction these proof of stake events that are happening in the weeds of the proof of stake consensus, and are just statements about some block, about the status of the block, and these events are going to be propagated to the execution layer. And this is how the communication happens and how the communication is specified in this document. So let's just, here is these three events. Let's just go through them one by one. We have this consensus layer on the left, execution layer on the right. So the block gossip, let's just suppose a short story from the communication of these clients. Let's suppose it's that there is a new block coming from the block gossip on the consensus side. It does some pre-validation here of this block, like checking the proposer signature. If it's valid, then this block is sent to the execution layer in order to check the execution, whether this block is, whether it actually sends not the beacon block, but it sends the execution payload to check this payload with respect to the execution with respect to state root. Yeah, and yeah, the consensus layer keeps processing the beacon block and yep, executes the state transition, the beacon state transition, and once it's executed, it sends the proof of stake consensus validated event to the execution layer, which says that this block is either valid or not with respect to the consensus rules. Yeah. In the meantime, the execution layer keeps executing a block and sends the response back to the consensus layer. And here is the whole cycle of block processing here. So if this response says that the execution part of this, the execution payload is valid, and if this message says that the consensus rules are valid, this block is valid with respect to consensus rule, then this whole block is considered as valid and can go to the chain storage. Next, after processing this block, the consensus layer triggers the fork choice. It's separated here because the fork choice trigger is not only the on block event, but only an on attestation event. So when the attestation comes from the wire, it's different from the proof of work where each block is self-sufficient in terms of the fork choice. So once the fork choice triggers here, and the block is designated as the head of the chain, it's communicated down to the execution layer. So it may and it must take the according action. So set this block as the head of the chain. The same happens with when the block is finalized. In the best case, the block is finalized to epochs after it's been imported. So, and the respective message is sent to the execution layer, so it can be aware of finalized blocks and expose this property, the block finality, to the users. Okay, this is about the event. The next step, okay, we've been talking about the abstraction of consensus layer, now the new hard fork mechanism. So here we have the core concept, which is called terminal total difficulty, which actually triggers the transition process, triggers the merge. We will speak about why this happens upon the total difficulty reached by the network on the next slide. But anyway, so once the terminal total difficulty is reached by the network, there is the first block that reaches this total difficulty is denoted as the terminal proof of work block. So literally, this will be the last proof of work block in the network. So the last block built by the proof of work. So we have this terminal proof of work block, which is signified by the terminal total difficulty, and the first proof of stake block produced as the child of this terminal proof of work block is called transition block. This is what we usually were referred as the fork block, but since this is a kind of a bit different hard fork mechanism, we decided to use this name transition block instead of fork block to not confuse anybody, because fork block usually goes to the configurations, like there's a chain configuration of Ethereum mainnet clients. I think that this transition will be different in that regard. So that's why the different name here. So we have once again, total difficulty triggers the transition and signifies the terminal proof of work block. The next block produced on top of it is going to be the proof of stake block. This is by design, and it's called transition block. So yeah, why terminal total difficulty? Why not using the predefined hard fork block number as other regular hard forks? That's because of this kind of attack where one party may, an adversarial party may create the minority fork, the fork which has been produced by the minority of hash and power. And then this minority fork can satisfy this block number requirement. And it could be revealed right before the merge, or after the merge already happened on this adversarial fork. And yeah, that's it. It will be then finalized by the proof of stake, and this minority fork will be the canonical chain, will become the canonical chain. It also may carry the double spend attack in this fork. This kind of attack requires the malicious proof of stake, malicious beacon chain proposer. It could be bribed, or it could be like belong to the same adversarial party. So because they have some freedom here to decide when this, when to reveal this block, and yeah, they can juggle between one proposer and another and wait for their turn to propose and so forth. Yeah, but still it's possible. Following the total difficulty rule, following the terminal total difficulty rule introduced by the specification, we are enforcing this transition process to follow the majority of hash and power and preventing this kind of attacks. So that's the rationale. It's exposed in the security considerations of this EIP. Yeah, okay, so I think now we're ready to go through the transition process while we explain these new terms and new mechanics. So let's do this. Okay, so yeah, transition process. The transition process, or the upgrade, the actual upgrade, will be started with the beacon chain fork. The beacon chain fork is specified in ETH2SPX repository. Here is the link. It has like a few parameters. Like the major one is the merge fork epoch, which is very similar to the fork block number. So when this epochs arrives, when this epochs happens, the actual upgrade happens. So the structures are upgraded and the logic is upgraded. So it starts, okay, so the transition process starts with the software upgrade, which will deploy the beacon chain fork, the beacon chain merge logic on the consensus layer side, and also there will be a respective update on the execution side, which is which by this time will be still the proof of work chain, or Ethereum mainnet as we know it today. But it will still listen to the proof of work. It will still produce the blocks that are produced by process the blocks that are produced by miners, but it will start to listen to the consensus layer as well for further communication and for initiating the transition process. So this software upgrade will happen likely 4 weeks before the merge fork epoch as usual. And yeah, once the merge fork epoch happens, the consensus layer will compute the terminal total difficulty. We'll speak about this computation like a few seconds later. So, and then this computed terminal total difficulty is communicated down to the execution layer. So this is the first time these two clients starts to communicate. So to make the execution layer aware of this total difficulty and act respectively, we'll see how on the next slide. Okay, so this total difficulty is computed in the following fashion. We just take the anchor proof of work block. So that's the sum block that the beacon chain is agreed around, and we take its difficulty to estimate this terminal total difficulty. And we compute, we not compute, but estimate the proof of work blocks happen since this anchor block. And we also have this target seconds to merge, which is set to actually 7 days worth of seconds. And we compute target proof of work blocks to merge by dividing these target seconds by the average block, average proof of work block number. So we get this total difficulty offset, and then we add this offset to the total difficulty of anchor proof of work block. That's how the estimation is happening, how the computation is happening. Yeah, about this anchor proof of work block, we already have this mechanism, which is called ETH data poll or ETH data voting, that is driven by proposers and used to induct new validators by processing the deposit contract events. It also agrees on the block hash, and this mechanism is going to be used to obtain this anchor proof of work block. So once the merge fork epoch happens, whatever is in the beacon state, whatever ETH1 block hash is in beacon state is going to be the anchor proof of work block. That's it. Okay, so terminal total difficulty has been communicated, and we are roughly 7 days after this event has happened. And here is the where the actual transition starts. There is the terminal proof of work block, which happens and is tracked by the execution and consensus sides. So because the execution side, of course, it knows when it happens because it follows block processing follows the block processing on the mainnet, and yep, it's aware about this terminal total difficulty. Also, the consensus layer tracks this proof of work chain as well as it do today. Once this terminal proof of work block happens, so the first section of specification of this EIP comes into effect, and no other blocks, no descendants of the terminal block must be processed. We'll see the rationale in that later. Also, the networking stack should not send the descendants of the, here is the whole statement has been cut, but this is also only related to the descendants of the terminal block. So block gossip for descendants of terminal block should be stopped. Then once the proposer of the beacon chain proposer sees this terminal proof of work block, it takes this block and builds the execution payload on top of it, wraps it in, enshrines it into the beacon block, sends it to the beacon chain network over the block gossip, and this block received by the consensus layer of other clients is propagated down to the execution layer, and it's the transition block that we've been mentioning earlier. So this is our transition block, where a number of sections of this document comes into effect upon receiving this transition block. Here it is. Here is the consensus validated for this block, and here is just the usual processing flow for the proof of stake block. So transition block is the first proof of stake block, and all these things that are Yep, Micah, go ahead.
If the execution client receives a terminal proof of work block over the gossip network, but the block proposer has not yet received one, does that execution client just kind of sit and wait until a block proposer sees some terminal proof of work block?
Right. Yep.
And then if that's different than the one the execution client saw, then it will switch to that. Is that correct?
Yes.
Okay.
So it will wait, and if this, if this transition block is not valid with respect to consensus or execution, it will be just dropped by the network, and the next proposer will try to do the same to produce on top of the terminal proof of work block. That's, but in the happy case, it will go smooth.
Okay, thanks.
Okay, so next, as of the first proof of stake chain had set event, we have the fork choice rule switch over to the new one, and the transition process finished by the first block finalized event. And on this event, the block gossip that is in the execution chain, in the execution network stack should be must stop existing. So it just must be, those message handlers must be dropped. Yep, Micah.
Why does it wait to stop handling those messages until finalization? Why doesn't it stop handling them as soon as it sees terminal proof of work block?
That's a good question, and that's because there could be a temporal partitioning due to delays in block propagation. And if you see the block, and there could be several terminal proof of work blocks by design. And if you see the first one and you just stop propagating the others, it might be the case when this first one is not the one that is picked by the proposer, right? So proposers see the other terminal proof of work block and produces on top of this one, and so you will not be able to get this block and verify it. You will, yeah. You can probably.
I thought the blocks came from the consensus client at once they were.
Right, but
or is that not true for the first one?
Yeah, that's yes. It's not true for the terminal proof of work block. It's the proof of work block. So it comes from the proof of work network. And
I see. Okay.
Yep, and it's important to process as much terminal proof of work blocks as you can and keep processing them until some point in time. And the best point in time for this is this finalized event. Yep.
If I understand correctly, the execution client will continue witnessing and seeing and processing every eligible terminal proof of work block until such time as the consensus engine finalizes one of them. And then at that point, it now knows for certain that it has the terminal proof of work block that will live forever, and it can then drop all the rest and it can stop processing them.
Yeah, okay. Yeah, that's exactly as you have described it. Okay. So yeah, so that's the transition. It's a bit tricky, but I hope this diagram helps to understand what is going on, what is supposed to go on. Okay, so let's go briefly through specification. It's not that tricky as the transition process. Yep. Why you stop processing perform blocks? Just suppose that. So it's all exposed in the security considerations. So you may go and check on the EIP. And yeah, suppose that there is the consensus layer, the part of software, of client software that is responsible for a consensus for the beacon chain is goes offline before the transition and stays offline for some time. And during this period of time, the terminal proof of work block happens and transition happens. And in this case, the execution client will not receive anything from the consensus side and will keep producing proof of work blocks, even if those blocks will be, if the proof of work chain will be kept building beyond this transition block. So if somebody will decide to keep mining blocks, and in this case, execution client will track this wrong chain, which could lead to like adverse effects such as the incorrect state of the client, where the syncing from scratch will only help once the consensus side gets back from its offline. Or in the worst case, it could be the some security issues if this happens, if such a thing happens in the services or any applications here. So yeah, and to prevent this like security violations or just inconveniences with the clients, with the irreversible client state, this this requirement is enforced. So it just stopped producing the proof of work blocks and wait for the comment from the consensus layer. And so we're like doing this in favor of doing these potential security issues and removing them in favor of liveness issue. So it will just not be updated, which is better than be updated with the wrong information. Okay, so the block structure remains the same, and we do this by replacing the fields that are deprecated. Mostly those are deprecated because of proof of work deprecation. We just set them to a set of constants, which are exposed here. Pay attention to the extra data that is going to be deprecated. But probably it's important for you. Just go and to this PR with this EIP and comment out on it if it is. Block validity is also changed, and obviously this is due to proof of work deprecation. So all these rule sets that are related to verifying the ETH hash and OMERS should be removed. And it is replaced with this proof of stake and consensus validated event, which is applied here. Also, it implies that if the chain head set or block finalized events are sent, are linking to some block, then it implies that this block also valid with respect to the consensus rules. So they should be treated as the same, as the events with the same semantics as the consensus validated one. Also, there is the verification of the fields that those fields are set to appropriate constants, those fields that are deprecated. We are removing block and OMERS reward. So the EIP removes them, but transaction fee mechanics stays the same. It's not affected. The fork choice rule is going to be altered on the first chain head set event. It's just as follows. It's very straightforward. What is sent in this, what block is referenced by this event becomes the head of the chain, and this chain becomes the canonical blockchain. And also the block finalized will contain the information about the chain head set event as well. So just to avoid consistency issues, there is potentially these two events could be combined together, but we'll see. We'll think about it more. Network stack. This is just for like reference. This is all about block gossip, which is going to be deprecated, and that's it. Not much to say here. Yeah, I would like to say about backwards incompatibilities. Though this EIP does not introduce any changes to the EVM, but there are two implicit changes. First one is affects the difficulty of code, which will return the 0 because of the constant, because of replacing the difficulty field with the constant value. But there is the idea of change this difficulty opcode and expose the randomness accumulated by the beacon chain, which is also known as RANDAO, by this difficulty opcode. But this change is going to be introduced by another EIP, and the idea is to take this difficulty opcode EIP into effect during the merge. So it will be like this change will happen at the same time as the merge. Regarding the block hash, so some of existing smart contracts may use the block hash as a source of randomness, as a source of pseudo random numbers. And after the merge, the randomness of these numbers will become completely insecure, because it will not be secured by proof of work anymore, and the block will be malleable and will be easy to change by the hash of the block will be easily changeable by the block proposers, by the block producers. So if anybody has their smart contract heavily depends on the block hash as a source of randomness, without combining it with difficulty, you should be worried about it, and yeah, you should go and just reach us out and discuss how to potentially avoid this kind of break and change for this block hash, for this alternative block hash semantics. That's all. There is a TBD in this EIP. They are in the tests and reference validation sections, which is not that important, but there is the further threat analysis in the security consideration section, which is important and will be introduced later on, as long as the R&D part of these things will be finished. Also, what to expect is the difficulty of code EIP, the consensus API that will cover the new block, that will just cover the communication between consensus and execution layer, including the new block and assemble block and this kind of stuff to produce and import blocks, and also which will cover these proof of stake consensus events that we have mentioned. Also, there is a number of things that is to be done to deliver the merge on the mainnet, and you may check this list for them. So, yep, here is some references for you that has been used here: the beacon chain specification, the EIP pull request, and the R&D Discord for discussion. Join it. We're always welcome to discuss the merge and the stuff around it. Track the progress with the checklist. Follow me on Twitter, and that's it. Thank you so much. I'm ready for questions.
Thank you so much for the presentation. I understand this proposal is in the early stages of discussion as well as documentation, so we can expect changes. But to get a feel of what the community thinks about this proposal, we shared a Reddit post to collect comments, questions, or any concern about this PR-3675. And we have got some questions for you. In general, because the merge is a big overhaul, the community has mixed questions from different proposals and features as well. So my first set of questions is related to the topic of third-party providers. The question, I think it is coming up from the client team of Ethereum 2.0. It's how will ETH1 services like Infura work when proposing blocks, or will the merge require the validator to run their own instances of execution, the client to receive the full reward?
Yeah. This is about using Infura. Okay, so let me show you something here. Do you see my screen? Do you see this merge readiness checklist?
Right.
You can see this on this section here. And here is the execution layer proof of custody. It's on the list. It will not likely go into the initial merge, but will be introduced later. And it means that every validator will be enforced to run the execution client aside of your beacon chain client software at some point. So probably Infura will, I don't know, will not expose this, execution layer service to be able to defer your execution duties to this kind of service because of this proof of custody.
So there are a couple of more questions, I think, on the similar topic. Have you heard from third-party providers such as Infura, Alchemy, what this means for their offering, especially how they will handle the coinbase and distribution of priority fees on the block proposals?
Yeah, that's a good question. Yeah, I haven't heard from third-party providers from any of them. So yeah, there is definitely a number of ways to how to handle this. So they could be, the Coinbase could be a smart contract, or it could be talking about these block proposals. So they will not likely be exposed by third parties after this proof of custody. But if they were like for a short period of time, the Coinbase, all the fees that goes to the Coinbase could be shared between the service and the client. It could be, I guess, it could be done in even a trustless way when the service returns you a payload which sends some funds back, which has a transaction that sends some funds back to the Coinbase that you have provided, and so forth. It also could be the case, like speaking of this topic, the Coinbase could be passed along the assemble block request from the validator to be inserted in the execution payload. This is one of the options for probably staking pools and some other services to handle this Coinbase stuff.
So it's something to keep in mind. We very much want validators to run their own execution client, which is why that R&D item is listed there, the proof of custody stuff. And so I do recommend people do not expect off-the-shelf consensus clients to facilitate like this sort of trustless interaction with third-party execution clients. Really, you should be running your own execution client. You should not be relying on someone else to run it for you. And while in theory it is possible, as Mikhail indicated, to do some sort of trustless thing, I think Rocket Pool is setting up something like this. It's something that will probably not be actively supported, I suspect. Correct me if I'm wrong here, Mikhail, but that's my understanding.
Yeah, right. Even though if there will be the possibility to outsource your execution duties to some kind of third party, just keep in mind that at some point it will be enforced to by this proof of custody for execution to run your own execution client. So it's better to be done earlier than later.
Yeah, and similarly, whoever you're outsourcing your execution client work to, by default, they have full control over the block that's being produced, and so they can produce blocks that are just malicious, like are invalid, and if they wanted to try to slash you, as an example. Similarly, they could produce blocks that just give all the transaction fees to the block proposer. So be very careful if you are relying on third-party execution clients who you are trusting to do that. There's, like I said, there's nothing built in to make that a trustless operation. And so if you do point at Infura or Alchemy or something, we can't stop you, but it's on you that you're trusting them to do something that you're on the hook for. Like you're committing that whatever they do, I assert that is true. And even if they do something that's not right or not good. So keep that in mind.
Yeah, and add here some kind of MEV stuff. So there are potentially some ways of extracting MEV that does not go to the coinbase. And
Yeah.
Some of the MEV opportunities might be lost by using these third-party services, which is, which is just worth than producing it yourself by your own execution client.
Interesting. There's one maybe last on this topic. Oh no, that is something related to validators reward. So will priority fee going to the validators after the merge be assigned to whoever was randomly chosen to produce that specific block, or will it be evenly distributed to every active validator on the network?
So it will go to the actual producer of a block. That's why it's important to use your own execution client, because you're in control of it. So it's not gonna be distributed, across every active validator in the network.
Right. So another one coming up for the validators reward. What do you expect rewards to look like for validators in short and long time frame post merge?
That's a very tricky question. I don't think we. What I'm doing what do I expect? Yeah, obviously there will be transaction tips, right, and MEV opportunities that will increase the validator rewards, but it depends on your setup. But anyway, it will be increased. Depends on the setup. I'm not going into the weeds of like using the staking pools or solo or validating or in a solo mode. So
I think there's so correct me if I'm wrong here, but there's no change in the staking portion of validator rewards with the merge. The only difference will be that block proposers will now receive priority fees and MEV. Is that correct?
Yeah, that's completely correct. Thanks, Micah, for this note.
So anyone who wants to get an idea, the places to research is you can just go look at what your validator is making right now, or what validators are making right now, and it will be similar. Like as more validators come online, rewards go down. So keep that in mind. I think the Ethereum 2 Launchpad has a nice chart that shows, what long-term yields are like. That's the staking portion. And then for the block rewards portion, there are a number of community-driven dashboards online that show both MEV and transaction fees to block producers right now, and you can take a look at those. So just make sure you subtract out the 2 ETH block reward, and everything else will now be going to block producers in proof of stake. Keep in mind that EIP-1559 is going to change that a little bit. So after London, which is next week, those charts will change. So if you're looking at that today, it's going to be a little different than if you look at it in a couple of weeks.
Thank you. I know we are almost hitting an hour. There's another set of questions that is related to difficulty of I remember there was this slide where it is under the section of TBD, but I'm just relaying the question in case we have something on that. What is the recommended way for a contract to access randomness?
Yeah, the recommended way after this mentioned difficulty of code EIP will be accepted and comes into effect, which will happen at the point of merge, which we expect to happen at the point of merge. This is just going to be to use the difficulty of code for randomness, which this randomness accumulated by the beacon chain is much more secure source of randomness than the block hash and the difficulty, or all of them combined together.
Right.
And just for messaging, so people don't get confused, the opcode currently called difficulty, I forget what number it is, most likely we'll colloquially rename that to randao or something to make it more clear that this is a source of randomness and not actual difficulty. So if you see in the future references to like a randao or random opcode, again, the number will be the thing that is currently the difficulty opcode today. Those names for opcodes, difficulty or whatnot, are not actually the code, just uses a number everywhere. So the renaming is just sort of a social consensus thing that humans do.
Yeah.
Right. Yeah, we have a kind of follow-up on that as well. Like, is there a rough plan to include EIP-3675 and EIP-TBD, which reintroduces the source of randomness to difficulty in the same fork?
Yeah, that's the plan.
Awesome.
And so existing contracts will just use this difficulty opcode. I mean, it will just work for the randomness purposes.
Right. So there is this one last question. I know, I mean, this may be a question for miners community to decide on, but people are curious to know what our guests think on that. What do you think miners will do after consensus is changed? Do you think they will keep mining the old ETH POW chain, move their mining power to the blockchain, or capitulate and join the ETH2 as validators?
In my opinion, that all these may happen at the same time. So I don't have any preferences, and I'm not thinking about it. Once the merge happens, the Ethereum mainnet will be not dependent on the proof work anymore, and it will be really indifferent to what happens with the these proof of work. The proof of work continuations of this proof of work chain that it's been relied upon. So if somebody keeps mining it, okay, that's okay. If not, that's also okay from this standpoint. Of course, the join as validator I think it's a good option, but I'm not like a miner to reason about it.
Thank you.
I suspect we'll see a lot of people going into becoming YouTubers, showing the destruction of video cards in interesting ways. Yeah.
That's quite a suggestion. All right. Ethereum, with over a 260 billion USD market cap, is the largest blockchain to undergo such a huge change. And this is not only affecting the block structure, block processing, fork choice rule, but also the model of the network security provider. I suppose there is still room for value change in another section, as some of them are still TBD. I'm also confident that we are going to see more questions as the process will evolve. Once the proposal is merged to the main EIP repository, we'll get more reviews. So as for now, thank you once again, Mikhail, for taking out time to talk about EIP-3675 and the merge. And because the proposal has just started taking shape, I hope I would see you at least one more time before the actual upgrade. So any last comment for the community out there who are eagerly waiting for this proposal and the merge?
Thanks again for inviting me. That was great to be here and present this huge thing, which has a lot of efforts behind it by different contributors, starting from researchers and developers, for like a decent amount of time. And I'm very excited to see how this is progressing and how this is starting to gain more focus. And we'll see what will happen in the next few months, but I guess it will be a really exciting journey. So
yeah, thank you very much, Mikhail. Today I learned that people live in Siberia.
Yeah, thanks, Mike, for facilitating the discussion.
All right. On this note, for all our YouTube viewers, thanks for watching. If you like it, please share it with people of similar interest. We have added guest Twitter handle and the presentation links, along with all the references, resources in the description section. So as usual, we'll be looking forward to your feedback. You may leave a comment. I read them all. Reach me on Twitter at Pujaranjan19 or the Cat Herders team on ETH Discord. Next, on the Ethereum anniversary special episode, we have invited Vitalik Buterin to give a talk on blockcast limit. So stay tuned, keep watching, and keep sharing your love with Ethereum Cat Herders. See you all in the next episode of PEEPanEIP. Cheers.
Thanks a lot, Pooja. Thanks, everyone.